Hi, I am Faisal. This is Module 7 Raster and lesson number 3. It is about terrain analysis in QGIS. So let's get started with this tutorial. So in this lesson, we have steps, following tasks. First, we will calculate hillshade. We'll also try to understand what hillshade is. Then we'll use it as overlay to create a 3D look. Then we will find the best area from the given raster based on some conditions. We'll calculate slope, aspect, and then continuing the best area exercise, we will find north facing direction. All those raster pixels are those locations which in which slope is facing north direction. Then we will carry on the exercise of best area with performing more criteria, performing more calculation. Finally, we'll combine our raster analysis results. After combination, there will be some area which will need to be discarded. So for that, we will simplify the raster analysis for a reason that those areas will be very small, in which it will be not possible to construct a house. We will then reclassify our raster. This will be another analysis, then aspect. In this, we will convert the aspect file into 4 direction. Then finally we'll perform query. In query, we'll be using the identify feature tool as well as a plugin. And finally, we'll conclude our this lesson. Let's talk more about the problem of finding best area. Suppose we are in the southern hemisphere of the Earth, and we know that an ideal location for development will be the area with following 3 conditions. Suppose you want to make a cottage, a house, a building. So if it is facing north and if you have slope, you would avoid high slopes. You would need slope to be either 5 degrees or less. And if there is no slope, how to detect the area which are flat. So in case if you want to detect area with no slope, so you need a limiting value after which you will consider that the area is flat. So 2 degree, if the slope is less than 2 degree, we will consider that land as flat land and expect the direction of the slope in such land would not matter. It will not matter. It will be of no value, of no interest. So there are 3 conditions. We want an area facing north. If there is slope, it should be less than 5 degrees. If the slope is 2 degree or less, we will consider that as flat, and in that case the direction, the aspect would not matter. So in order to solve this problem, uh, we will be given a raster file. We will perform raster analysis, and which tool we will be using? First we will be using a tool from processing toolbox, inside which we have two sets. Either we can access our tools from GDAL, or we can access our tool from QGIS raster terrain analysis. Okay, so first you will go to processing toolbox, inside which you have QGIS raster terrain analysis, or a third party software GDAL, inside which you have the required tools which you can use. What are those tools? Those tools are Hillshade slope aspect. We will also use Raster Calculator, and then to choose the best location we will need identify features, and to choose to check many location instantly we'll need and their details instantly, we will need a plugin. That plugin is known as value tool plugin. Now you may also face some problem when you are performing this analysis, and the problem may be that you will be unable to find the processing menu. In the main menu you will be unable to find this processing command in the main menu. So if you are unable to find the processing command, because processing toolbar can be accessed from processing menu, and you are unable to find the processing menu, so in this case you will go to the plugin menu, then click on manage and install plugin. Okay, and a dialog box will open. In this dialog box you will activate a processing plugin. You will check that it is a core plugin which is installed with every QGIS uh, software. Now we will open QGIS software and continue there. Okay, so let's get started. We are in 7th chapter, module 7, raster. Now let's get started with terrain analysis. This time I'm using PDF. Just click on terrain analysis. This is the last part of chapter 7. I'll make full screen so that the text is more visible. Okay. Certain types of rasters allow you to gain more insights into the terrain that they represent. Digital elevation models, DEMs, are particularly useful in this regard. So there are certain raster which are more useful in terms of terrain, and one of those raster is DEM. In this lesson, you will use terrain analysis tools to find out more about the study area for the proposed residential development from earlier. So the residential development has been discussed in previous chapter. So we will be using terrain analysis to find more about the study area in residential development. What is the goal? To use terrain analysis tools to derive more information about the terrain. The first task is to perform the hillshade. We are going to use the same DEM layer as in the previous lesson. If you are starting this chapter from scratch, use the browser panel and load the raster srtm 4119.tif file. So let's do this. Uh, I'll start from scratch, discard, and I'm using this browser panel. In browser panel, I will use this srtm 4119. Here it is loaded. I have dragged that into layer, so it is loaded now. The DEM layer shows you the elevation of the terrain, but it can sometimes seem a little abstract. So DEM gives you elevation, but this elevation information is abstract. It contains all 3D information about the terrain that you need, but it doesn't look like a 3D object. Although it gives us information about 3D, but it is not looking like a 3D object. To get a better impression of terrain, it is possible to calculate a hillshade. That's why we need hillshade, which is now here we have definition of hillshade, which is a raster that maps the terrain using light and shadow to create a 3D looking image. So we are when we use a raster, which is mapping for us the terrain, and terrain is mapped with the help of light and shadow, and the result is 3D looking image. So this is known as hillshade. So what we are going to do, we are going to use the algorithm raster menu and then go to raster terrain analysis. Now note down here that in this was in previous version of QGIS. In new version of GIS, you will go to raster and then analysis. There is no term as raster terrain. So you will go to raster and then analysis. And inside analysis, click on hillshade. Okay, so let's do this. Raster analysis hillshade. The algorithm allows you to specify the position of the light source. So this algorithm first specify the position of light. Azimuth has value from 0, which is north, through 90, means east, 180 south, and 270 west. So azimuth is actually an angle measuring from north, and it spans to all the it span across all four directions. While the vertical angle sets how high the light source is from 0 to 90 degrees. In order to measure the light source, which is sun, we have to provide two angles. One is horizontal angle starting from north, the other is vertical angle pointing to the sun. So here they are talking about these two angles. Now for our analysis, we'll use Z factor as 1, azimuth, the horizontal angle as 360 and vertical angle as 40. So here we have the diagram. So this is sun. So if you are standing at some location, so at this point the sun is at particular angle, okay, say 40 degree, and it has azimuth angle, which is angle starting from north, as 300. So let's just give this information. Input layer is already picked by the QGIS dialog box of Hillshade, SRTM 4119. Band is gray. Z factor is 1. It is vertical exaggeration. Scale is 1. Azimuth is 300. So I'll select this and make it of light is 40 degree, 40 degree altitude of light, and then we'll use this information. Else, save the file in new folder, which is exercise data. The name of new folder is raster underscore analysis, and the name of file will be Hillshade, and then we'll press the run button. So let's do this. Here at this moment it is saved to a temporary file. So I'll press this save instead of temporary. I'll press save to file. I'll here my data is in my document, so I'll go to document, and in document then I'll go to QGIS training data exercise, and here let me see whether I have raster analysis. I don't have raster analysis, so I'll create a folder, new folder. Oops, there's a problem, that item not found, and here I have some virus and threat protection, which says that control for access blocked QGIS from making changes. So basically, window has some protection in window 10s, and window 11 there is protection that unauthorized changes are blocked by programs. If there is a software or executable, so that executable cannot make changes to my folder in Windows. So QGIS is being blocked by window protection to make changes to my documents. So how I can change this? I'll click on this notification. So here I am looking at the protection history. This is the last protection which is shown. I will click on this. You may see a black screen, but here I have a user access control of Windows security. It is asking me, should I proceed? Should I allow this app to make changes? I say yes. Now here, what was happening is that QGIS-build executable file was making a new folder inside this path, and this was blocked by control for access. So let's allow this action allow on this device. Again, again you may see black screen, but it is a confirmation of user access control, Windows security. It is asking me to allow the changes, allow this app to make changes. So I will say yes. And after making this change, I'll minimize and I will try again. This time I'm able to create folder, and the name of this is click on this raster analysis, and the name of file will be Hillshade. We will now press run button. So I'll press run button, and see again same problem that Windows security is stopping uh, the program from making changes. So I'll click again. This time the protection, the setting is closed, so you can open it from here. Virus. Here we have virus and threat protection right down this word. And protection history. And here we have another protection history. It is user access control asking me to allow. I will press yes. So again now this time another tool is being stopped, another tool of QGIS. The name of this tool is jedal.dem.exe. So I have to allow this jedal.dem.exe as well. So go to action, allow on this device. You may see black screen, but here it is a user access control dialog box asking me that do you want to allow this app to make changes on your device? I say yes. So it is now allowed. Let's check again. So I'll go to this is log file. There was error, so I will go back to parameters and I will run again. This time the run is successful, process completed successfully, and here a hillshade is created. I will press close button. So now we have a 3D look, a shade, some places are light color, some places are having shade. Now the hillshade look like this, as you have seen. That looks nice and 3D. But can we improve this? So now we are going to improve this further. On its own, the hillshade looks like a plaster cast. Yeah. Can't we use it together with our other more colorful raster somehow? So it just look like a plaster. So we need to make it colorful. Of course, we can by using the hillshade as overlay. Now the next task is to use hillshade as overlay. So how we can do it? A hillshade can provide very useful information about the sunlight at given day at given time of day, but it can also be used for aesthetic purpose. It gives us information about the sun and its shade, but it is also useful for aesthetic purposes to make map look better. The key to this is setting the hillshade to being mostly transparent to make it more attractive and aesthetically good. We'll make it transparent, little bit transparent. So how we can do it? Change the symbology of original 41 SRTM 4119 layer to use pseudo color scheme as in previous exercise. So we are going to change the color to pseudo color. Hide all layer except SRTM 4119 and Hillshade. Okay, so let's do this. So I will change the symbology of SRTM layer. So I will select the SRTM layer. I'll open the styling panel, and here I will change the symbology, the style, and the style will be changed to, instead of single band pseudo color. It is not visible, so I will uncheck the hue shade first to see it. Now it is like this. Um, Here they are using some other color combination, but we can use this one as well. You can adjust the color ramp, color 1 and color 2 by clicking here, or if you drag down and then you can select some other color from this menu. Okay, let me select the spectrum and let me click here on the ramp, and I will change this combination. So this one is let me check it here. So I'll come here, I will copy this color, then I'll come here and I will paste this color. And now color 2 will become the first one. So here I'll select the red. Now it is moving from blue to red. Press OK. Now this is somewhat similar to, is now reverse of the first one. It is now somewhat similar to what being showed here. They have some other combination. I think it is from purple to uh, yellow. So let me try to find this one, purple to yellow. So let the second color be a yellow color. Sit. Again, it doesn't seem okay. Press OK. Now we have and let make the first one as somewhat like this. Now, okay, the first color is a little bit darker, and second is I think okay, so I have to make it more dark. So almost similar. It's all about making the it's all about choosing the right color. If I come here, I think I will now close. Yeah, it's getting closer. So you can try, you can select colors and you can make it closer, or you can make your own combination the way you want. For the time being, I am using this combination from indigo to yellow. Okay. Now, what else I will do? Hide all layer except SRTM and Hillshade. So I'll make these two visible. So Hillshade and SRTM both are now visible. Then click and drag SRTM to be beneath the Hillshade in the layer panel. So make sure that SRTM is below the Hillshade. It is already below the Hillshade. This is okay. Set the Hillshade layer to be transparent by clicking Transparency tab in the layer property. Set global transparency, global opacity to 50%. So select the Hillshade, transparency, and opacity should be 50%. It is now 50%. And now look at this image and compare to this, and it is have green areas, and then after green we have yellow. So uh, it's all about uh, the choice in the color ramp. So it depends upon how you choose the choice in your color RAM, the color will be adjusted accordingly. Okay, so I think for the time being this color is okay. Now let's move on. Switch the Hillshade layer off and back on in the layer panel to see difference it makes. So now if you see here, this is giving us a 3D look of a terrain. If I off the Hillshade, check the difference. See, if you turn off the Hillshade, it looks 2D. But if you turn on the Hillshade, it gives you a 3D look. Okay. Using a hillshade in this way, it is possible to enhance the topography of the landscape. So the topography is improved. If effect doesn't seem strong enough to you, you can change transparency of the hillshade layer. But of course, the brighter the hillshade becomes, the dimmer the color behind it will be. You will need to find a balance that works for you. Remember to save the project when you are done. So you can adjust the transparency, you can adjust the color, and when you are okay with, then keep that setting. And also remember to save your work. Let's save the project. Save, and we will save project in document. In the document, we'll go to QGIS, raster analysis, and here we'll save our project. Let it be so. Let's move on now. Come to the next part, finding the best area. This best area is based on some conditions, uh, three conditions. So let's understand it. Let's read about it. Think back to the real, think back to the estate agent problem. This problem was discussed in previous chapters, which we last addressed in vector analysis lesson. Let us imagine that the buyer now wishes to purchase a building and build a smaller cottage on the property. In the southern hemisphere, we know that an ideal plot for development needs to have area on it that satisfy following conditions. So um, here they are talking about northern hemisphere, southern hemisphere. So in southern hemisphere, ideal condition for a small cottage, for a plot, for a house is following. And now we are solving the property problem. So what is the first condition? The first condition that the plot shall face north direction, are facing north with slope of less than 5 degree. The slope of the plot should be less than 5 degree. And there is another condition, but if the slope is less than 2 degree, then the aspect doesn't matter. So you are interested in the direction of the slope. You are interested in the direction of the slope and the value of the slope, that it should be less than 5 degree. You want to have a less inclined slope, less inclined surface. And the third condition is that um, you want to if ignore the slope if slope is less than 2 degree, because in that case the plot will be flat. So let's find the best area. How we can do that? First, we need to calculate the slope. This is the next analysis which we will perform, and this is the next analysis after Hillshade. So, slope inform you about how steep the terrain is. If, for example, you want to build houses on the land there, then you need the land that is relatively flat. You need flat land for house, and slope give you idea about that. To calculate the slope, you need to use slope algorithm of the processing and then raster terrain analysis. So let's do that. We'll go to processing and then toolbox. In the toolbox, we will go for raster terrain analysis. So we'll go for terrain. Here we have a tool, raster terrain analysis, and in this we are going for slope. Open the algorithm, choose SRTM 4119. So let's open this algorithm and we will choose SRTM 4119. It is already chosen. Z factor is 1. Save the output as slope in the same folder as the hillshade and run. So Z factor is 1. Let's press this meatball button, drop down, save to file, and we'll go to document. In the document, we'll go to QGIS training data. Then exercise data. Raster analysis. And now this is the same place where we have Hillshade. Here I will save slope. Let's save, run the analysis, and slope is calculated. Press close. Here we have slope. I'll put my slope at the top of Hillshade. Here we have slope information. The value, darker value mean black values mean zero slope, light value mean highest slope, 83 degree, up to 83 degree. Now you will see the slope of terrain, each pixel holding the corresponding value of slope value. Black pixel show flat terrain and white pixel show steep terrain. A similar image which we have in the result. Now the third analysis is to calculate the aspect. Aspect is the compass direction that the slope of the terrain faces. So it gives us the direction of the slope. An aspect of 0 means the slope is north facing. 90 means east facing, 180 south facing, and 270 west facing. Since this study is taking place in southern hemisphere, property should ideally be built on north facing slope so that they can remain in the sunlight. So you want your property to face the north direction because you want to have maximum sunlight. And this is based on the property in the southern hemisphere. Okay. So where is aspect? Use the aspect algorithm of processing raster terrain analysis to get the aspect layer saved along with the slope. So let's do that. So how we can do aspect? Here you have in processing toolbar raster terrain analysis. Click on the aspect. Input layer will be elevation layer. Okay. So the input is elevation layer. It is the aspect of the digital terrain model. So I'll go for SRTM 4119. Z is 1 Z factor, and the name of aspect will be saved to a file, and it will be following. Save and run. Press close. So here we have aspect analysis. Now we will find our condition north facing direction or north facing aspect. So how we can do? Now you have a raster showing you the slope as well as the aspect, but you have no way of knowing where ideal conditions are satisfied at once. Now we have a raster in which we have slope and aspect, but ideal condition is still unknown, where our criteria of slope and our criteria of aspect is matching. It is still unknown. How we can do? How could this analysis be done? The answer lies with Raster Calculator. So that problem which was given that we need to satisfy these three conditions, this kind of problem can be done with the help of Raster Calculator to satisfy the north facing slope of 5 degree or less, and if slope is 2 degree, then ignore the aspect. So this will be done in the raster calculator. So how to open raster calculator? Go to raster calculator, or from the processing toolbar, raster analysis, and then raster calculator. Let's do this. You can also have raster calculator in the GDAL and Saga. In GDAL it is in raster miscellaneous, in Saga it is raster calculus. Each tool is leading to the same result, but syntax may be slightly different and the availability of operator may vary. So what we'll be using raster analysis, raster calculator. Okay, so in the processing, raster analysis, let me search raster calculator. Make it easy. Here we have raster analysis and then raster calculator. Click on this. Otherwise, you can have raster and raster calculator, or raster analysis, raster calculator. So raster calculator, or raster analysis and then raster calculator. So click on this raster calculator. Here we have adjust the size. Each tool is leading. Okay, now it is open. So open the tool by double clicking on it. Yes, I have done that. The upper left part of the dialog list all the loaded raster layer name at n, where name is the name of the layer, n is the band. So all loaded layer are listed here. One mean first band, and this is the name of the layer: aspect, Hillshade, slope, SRTM. These are the name. In upper right part, you will see a lot of different operators. Stop for a moment to think that raster is an image. You should see it as 2D matrix filled with number. So these are some operators, and just like we perform operation on matrices, so we should think of raster as a matrix on which we can perform these operations. Now northing is 0 degrees, so for the terrain to face north, its aspect need to be greater than 270 or less than 90 degree. So if you want your aspect to be in the north facing direction, it should be greater than 270 or less than 90 degree. Uh, so what should be the formula? Formula should be like this: aspect is less or equal to 90, or aspect is greater or equal to 270. Here you have the expression. So let's do it. Here I'm going to enter expression. Aspect is less or equal to 90. 20 or aspect is greater or equal to 270. Then now you have to set up the raster details like cell size, extent, and CRS. This can be done manually or it can be automatically set by choosing a reference layer. Choose this last option by clicking on button next to reference parameter. So we will not set these options, cell size, CRS. We will set it from the reference layer. Okay. So how this can be done? We'll be clicking on the three dot button, the meatball buttons in the uh, reference layer parameter. Okay. Okay. So let's give this a try. In the dialog, choose aspect layer. So our reference will be aspect layer because we want to obtain a layer with the same resolution. Okay, let's make it clear. Save the layer as aspect north. Okay, now a reference. Here we have a reference layer. So here I will press this three dot button and I will select the aspect. Okay, and press OK. One layer is selected. Output is drop down save to file and aspect or north. Press save button. So our option should look like this. Yes, it is like this. And let's run the analysis. Finally click on run and you will see results somewhat like this. So let's run the analysis. Okay, so again we have some error. And this time we are running a command. Let me check the parameters here to see if there's some. Let me check this Windows security. Okay, again another program is blocked. No, it is not blocked. Okay, the expression is not valid. This was the problem. So I think this or is not written correctly. I'll press this button or need to be kept. Now I think expression should be valid. Let's run it. And we have problem. Let's go for parameters. Let's arrange this. Less or equal to is, I think, not correct. There is space between less and equal, and here the less and equal does not have space. So move the space here and space here. I think now this one is correct. Let's add this space. Now this expression is valid. Uh, Let me read that again so that the confusion. Aspect is less or equal to 90. Let's say again 90, or aspect is greater or equal to, click here again, to 7. Press the run. Now I think run is successful. Execution completed. It means the run is successful. Okay. And we have, if I close this window, we have expect not calculated, having value 0 or 1, yes or no. Okay. So these are this white color is the area, the cells where which are facing the north direction. Okay. It's similar, the our result is similar to like this. The output value are 1 or 0. What does it mean? It means for each pixel in the raster, the formula we wrote return whether it matched the condition or not. Therefore, the final result will be false 0 and true 1. You can check more condition by yourself. What are those? Now that you have done the aspect, create two new layer from the DEM. The first shall identify all areas where the slope is less than or equal to 2 degree. The second is similar, but the slope should be less than or equal to 5 degree. Okay, and we will save that as a slope lte2.tif slope underscore lte5.tif. So we need to do this by ourselves. It is not explaining this manual. So let me do this. So the first one is slope, which is less than or equal to 2 degree. Okay, which is written here slope LTE 2. So let's do that. I'll write here slope. I'll use slope from terrain analysis. Input here is SRTM. Z factor is 1. Uh, I do have a slope with me. I think I need to use the raster calculator for calculating the slope which is less or equal to 2 degree. So let me use raster calculator for that. Go for raster analysis, raster calculator again, and I will write expression here as slope is less or equal to 2 degree. A reference layer is slope, and output layer is slope underscore LTE2. Expression is valid. Let's run the analysis. It is done. Now come here again and repeat the same for 5 degree. So instead of 2 here, it will be 5 degree. And then run, the name of file will be 5. Run the analysis and now close. Now we have slope LT5, slope LT2. Okay. Now what is follow along? Now we are going to combine some results. Now you have generated 3 raster from DEM. What are those? Aspect north, terrain facing north direction, slope LTE, slope equal to or below 2 degree, slope LTE5, slope equal to or below 5 degree. Now, where the condition is met, the pixel value is 1, else where it is 0. So in all these created files, we have value of 0 and 1. Therefore, if you multiply these raster, the pixel that have value of 1 for all of them will get a value of 1. The rest will get 0. So if you are going to multiply uh, these raster, so 1 multiplied by 1 multiplied by 1 will give you 1, otherwise you will have 0 value. The condition to be met are following: that at or below 5 degree of slope, terrain must face north direction. At or below 2 degree of slope, the direction that the terrain face does not matter. So what the condition becomes, therefore you need to find area where the slope is at or below 5 degree and the terrain is facing north, or the slope is at or below 2 degree such terrain would be suitable for development. So actually, here the discussion is about how we should write our expression. So to calculate the area that satisfy these criteria, open raster calculator and write down this expression. So we have two conditions. This is the first condition and this is the second condition. Second condition is that slope is equal to 1. Slope less or equal to 2 is 1, which means that our slope is 2 or below 2. How you will write here that your slope is 2 or below 2? You can write it this way, that you say slope underscore LTE 2, which contain all the slope which are 2 or below 2 value. So if this is true, so you say this is equal to 1, mean that all the slope which satisfy the condition that it is less or equal to 2. This is the one of the condition. The second condition to check is this one, that north aspect is facing north direction. So all those aspects which are facing north direction is true with you, and all the slope which is less or equal to 5 uh, is satisfied. So you say it is true. So you are actually comparing different true values. You are checking for a condition in which north direction and slope less or equal to 5, they are true. At the same time, if this condition is not met, you are looking for the condition in which slope is less than or equal to 2, slope is less or equal to 2, and this condition is true. So you are looking for this condition or this condition. The first condition compares to, if I go back to the beginning, the first condition satisfy this thing, whereas the second condition satisfy this thing. So basically here you have actually this is your condition, but along with this you are also looking for this one, that direction of the slope doesn't matter if it is less than 2. Okay, now set the reference parameter to expect north. It doesn't matter if you choose another, they all have been calculated from SRTM. So we can choose slope, or we can choose slope LTE 5, slope LTE 2, but they have chosen the aspect north, and all of them are same because they are calculated from SRTM 4119. And then you will save it as all conditions dot diff. Okay, so let's do it. So open raster calculator, put your bracket first. In the bracket you say that your expect north is true, so you say equal to 1, equal to slope less or equal to 5 is also true. Your condition that the plot is facing north direction, this condition is true, and the condition of slope is less or equal to 5 is true. Both of them condition are true. Otherwise, you are checking for a condition that slope less or equal to 2 is true. Expression is valid. We will select the input reference. Input reference can any one of that they have chosen aspect north. They are all calculated from SRTM, okay? So you can choose any one of this. So I will go for aspect north, and output file. Output file will be all for save, and then you run successful, close it. So you have now this all condition, and this shows you in white color all those areas where our condition are met. So you should not make your house in back side of the hill, not even here, because you have no light. You should go for this area, this one area. Okay, you should go for this area and these areas. Let me explain. I'll explain in a while. So if you see, our result is just like this one. Let me explain this for you. I'll take a snapshot. So what is recommended places? So the white color, this is the white color which you are looking at. Those white color, these are the places where sun is visible. These are portion of land on which you have sunshine. See, and you should choose your house in these regions. I am highlighting you this region roughly, or any of small white regions as shown. So all these white places are valid for your site to be used as cottage. All these white values. Okay, what they say, the previous step could have been simplified using following command. So we could have written our expression as following, that aspect 1 is less or equal to 90, or aspect 1 is greater or equal to 270, and slope is less or equal to 5, or slope is less or equal to 2. So if we had written this statement, and then this statement does not require creating aspect north or slope LTE5, slope LTE2. So you can run this command directly. Uh, if you use this statement, it does not require creation of it does not require creation of this file, this file, and this file. Okay, follow along. Simplifying the raster, we'll simplify our raster image. As you can see from the image above, the combined analysis has left us with many very small areas where the condition are met in white. So what are those small areas? Those small areas are these small areas in which the condition is satisfied. So we need to make this and much more smaller areas are these one. So we need to simplify our result, our raster. But these aren't really useful for our analysis since they are too small to build anything on. Some of the areas are very small. You cannot make house on these small areas. So what you need to do, let us get rid of all these tiny unusable areas. So what we are going to use open sieve tool from GIS raster analysis in the processing. Input is set input file to all conditions and the sieve to all conditions sieve under the exercise data raster analysis. Set the threshold to 8, minimum 8 contiguous pixel, or use 8 connectedness. So here we have that using sieve command, input is all condition, threshold is 8 pixels or 8 connectedness, and result is all conditions sieve. It will be run. Once processing is done, the new layer will be loaded. Okay, so let's do that. So GIS raster analysis. Let's search for GIS. In GIS raster analysis, and here you may find sieve command. There is sieve command. Here is all condition. Threshold is 8, or use 8 connectedness. What else you have? I think the other these options are not changed. Let me check again. Yeah, these options are not changed. Only the output file is specified. All conditions sieve. So click here, save to file, all conditions. And okay, There's some error. Let's try to figure out what is the error. Again, we have the virus protection. So let's click on this. Why? Because here I think new tool is being used. The name of that is GDAL underscore sieve.bat. New tool is used and it is accessing our folder of documents. So that's why. Let's go here and let's click here. Press allow. Press yes to allow changes and go to action. Allow on device. Say yes. It is allowed. Now let's run again. And this time the run is successful. It says process complete successfully and all conditions sieve is made. Okay, so let's see. And lid is also loaded and we see a picture like this having small black dots. So yeah, the picture is like this having some small black dots. So all these places are valid as per. So let's see what does it mean. Let me first see and then interpret it. What is going on? The answer lies in the new raster file metadata. So we have this white file. So we have to check the metadata, understand it. View the metadata under information tab of the layer property dialog. Look at the statistic minimum value. Okay. So right click, properties, information, and where we will look at statistic. We will look at statistic statistics minimum value under the information tab. Statistical minimum value. Let me check. Here I have information from provider. Statistics minimum is minus 2147. Is minus 2147. This raster, like the one it is derived from, should only feature the value 1 and 0, but it has also a very large negative number. And because of this negative number, we are looking at the result the way it looks. Investigation of the data show that this number act as null value. This negative number act as zero value. Since we are only after areas that were not filtered out, let us see, let us set these null value to 0. So again, we'll open raster calculator and we'll see that if the number is negative, negative means if it is less than 0, so make it 0. Okay, so let's do it. So raster calculator. Write down the expression starting with bracket all conditions underscore sieve at 1. If this is less or equal to 0, close and make it 0. In your mind that they should not be less than 0, they should be less or equal to 0. Also, select the reference layer, mid-pole buttons, aspect north, then specify the output file, drop down, save to file, and all conditions. The name I think is all condition simple. So it is all conditions, and then we have all conditions simple. Press save, and then let's run the analysis. Run is successful. It is finished. There is no error. Close it. And this is a simplified image. So let's see the comparison. So if I compare this with all conditions and see what's the difference, so I would toggle this on and off to see the difference. So you can see what the difference is, that there were small um, white areas in which our condition was true, in which we can make our plot, but these small areas are very very small than the area of plot, than the area of the cottage house. So with this uh, operation of sieve, we have removed these small areas which is below the size of our cottage house, and the result is in this all condition simple, this one. Okay, let's move on. Now we have this output just like this one. You have observed it. So what we learn from here, is that this is what was expected, a simplified version of the earlier result. Okay, this is what we needed. All small dots, white dots are removed. Now what we should take from this? We should take from this that remember that if the result you get from a tool aren't what you expect, view the metadata and vector attribute if applicable. What it can prove essential hint to solve the problem. So see, previously our result was not as per our expectation. Everything become true here. If you take this white color, so it means that everything is true. So this was not our expectation. So because of this statistic minimum value, a very high value. So by looking at, I will I will read this again, that viewing the metadata and vector attribute, if applicable, can prove essential to solve the problem. In case if you are not expecting the result. Okay, so this is a very useful hint that metadata can be very useful for resolving uh, your problem if you are not expecting what you expect. Also, vector attribute can be useful. Now let's move on. Reclassifying the raster. What we will do in reclassification, we have used the raster calculator to do calculation on raster. There is another powerful tool that we can use to extract information from existing layers. So up till now we are using raster calculator. There's another tool to use. And before using this tool, we need some conditions. Back to the aspect layer, we know now that it has numerical values within a range from 0 through 360. So aspect has a value of angle, which is the direction of slope from 0 to 360 degree. What we want to do is to reclassify this layer to other discrete value from 1 to 4 depending on the aspect. So the aspect layer has all values from 0 to 360. We don't want all direction. We want discrete 4 directions, in which one will be for north, 2 east, 3 south, and fourth will be for the west. Now north value will have angle uh, from 0 to 45 and 315 to uh, 360. This portion will be considered as north. The east portion will be considered from 45 to 135. The south portion will be considered from 135 to 225, and west 225 to 315. Let me explain with a figure what is happening here. Is take a screenshot. So we have north, and then we have other direction. Let me redraw this again. And south direction. So aspect cover all of this from 0 to 365. But I want to have discrete value. So what I will do is I will take value of this angle. And how much is this angle? If the angle is 45, or if the angle is 315, so this will give me this region, and I will consider this region as 1. So this whole shaded area is designated for north direction. Similarly, for them, I'll remove this extra information. Similarly, if I have over here, the angle is between 45 and the angle is between 135. So it will give me this region, and this region will be designated for east direction. Similarly, this region will be designated for the south direction, this one, and this region will be considered for, will be designated for west direction. Okay, so they are talking about this. So we need to reclassify our aspect layer into distinct four directions, and for this we will use another tool. So how we can do this operation can be achieved with raster calculator. Yes, using raster calculator you can perform such boolean true false. Based on true false value you can do this. On aspect we will perform in stages such calculation, but the formula will be very large. The alternate tool is to reclassify by table tool in a raster analysis in the processing toolbox. So I'll open this tool, reclassify by table, open the tool. So in here, reclassify by table, here, reclassify by table, open this tool. The tool is open. Choose aspect in the as the input raster layer. Our input raster layer will be aspect. So the raster layer is aspect. Okay. What else? Click on three dots, meatball buttons. They are just like meatballs, right? Meatballs button of reclassification table. A table like dialog will pop up where you choose the minimum, maximum, and new value for each class. So see here, we'll designate this for value, one for these angles and this angle, two for this angle, three for this, and four for this. Okay, so we'll press three dot button or meatball button for reclassification. Okay, so this is a reclassification table. Here you press this meatball buttons, and here you will add some rows. 5 rows will be added, and it will have these values. This one, that if your angle is from 0 to 45, you should say, you should designate a value of 1 for it. If it is 315 to 360, 315 to 360, again you should designate the value 1. If it is between 45 and, if it is between 45 and 135, then you should say it is 135, 225, 135 and 225, then it is 3. And if it is 225 and 315, then it is 4. 225, 315, it is 4. So 0 to 45, 315, 360, they are 1. 45 to 135, 2. 135 to 225, 3. 225 to 315 is 4. Go back. So let's check it again. I think instead of going back, we needed to press OK button, and I haven't pressed OK, so I will do it again. 5 rows. The first is 0 to 45 is 1. 315 to 45 to 45 to 135 is 2. 135 to 225 is 3. 225 to 315 is 4. Okay, so I have to press OK button, and here I have a 5 cross 3 table. The method used by the algorithm to treat the threshold value of each class is defined by the range boundaries. So the threshold values are defined here in the table. Save the layer as reclassified.tif file in the raster analysis folder. So we have this kind of information. Okay, so save it as save to file and reclassified. Press save button. Let's check the advanced option. 4 times of 9 and min value and max. They are just same. They are same like this one here. Float 32. Yeah, it is float 32. Click run. Let's run it. Run the analysis. Run is successful. Press close. And we have reclassified data here. If you compare the native layer with reclassified one, there are no big differences. By looking at the legends, you can see the value go from 1 to 4. So they say that there is no big difference, but the only difference, let's check that. Let me open this again. Okay, so let's compare reclassified with the slope. So in between, I'll remove the layers, all layers in between. Yeah, there is no big difference in the reclassified and the aspect. So if you see, they are almost similar. Okay, there is no big difference. And they say that the legend value will go from 1 to 4 in the reclassified. Yeah, it goes from 1 to 4 in the reclassified, whereas in the aspect it goes from 0 to 360. This is the only difference. Okay. um what else? Let's give this layer a better styling. We'll change the styling of this. Open layer styling panel, choose paletted unique value instead of single band gray. So reclassified is selected, open styling panel, and instead of single band gray, select paletted unique value. Okay. Click on classify button to automatically fetch the values and assign them random colors. So the color ramp should be random color, and we should press reclassify. So it is random color, and we should press reclassify, and we have the four values as shown. The output should look like this. You can have different color given that they have been randomly generated. Yes, our output is just like this one. And let me verify the input layer. The input layer should be reclassified. Yeah, input layer is reclassified. So this is our output. It is quite similar to this one. Follow along. Now we are going to perform some queries in the raster. Unlike vector layer, raster layer don't have an attribute table. In raster, we don't have attribute tables. The values, the extra data, non-spatial data associated with the layer. Each pixel contain one or more numerical values. If it is one value, we call it single band. If more than one, we call it multi-band raster. All the raster layers we use in the exercise consist of just one band. So all rasters have just one band which we have used. Depending on the layer, pixel value may represent elevation, aspect, or slope values. So each pixel value will represent either elevation. If it is SRTM, it will represent the direction. If it is slope, it will represent the direction. If it is aspect, it will represent the slope if it is slope layer. How can we query the raster layer to get the value of pixel? Important question. We can use identify feature button. So how to use this? Select the tool from the attribute toolbar. Click on the random location in SRTM. Identify results will appear with the value of band at the location. It will be somewhat like this. So let's do it. Um, this one. This is the identify feature, and it is available in toolbar. Which toolbar? Attribute toolbar. This one. So press this and select SRTM, and uncheck them, uncheck the rest of them. And in SRTM, if I click some value, so I will find the band value for this. Okay, the band value is 654 at location where I click, and you can see the change of value for each of the location. You can change the output of the identify result panel from the tree mode to a table mode one by selecting table in the view menu at the bottom of the panel. So here now same result but in the table mode. So it is changed by pressing this view option. So here we have a view is tree mode. So if I select here, now I have table mode, and there's third option available as well, graph mode. So I can see this point in graph. It is here somewhere 158 somewhere 185. Let me check that graph again. 185. Yeah, this value is 185. Yeah. And each value is plotted at 1 at horizontal, 1 mean band 1. Clicking each pixel to get value of the raster could become annoying after a while because you are checking one value at a time. So checking one value at a time can be annoying. Okay. We can use value tool plugin to solve this problem. We'll be using a value tool. So how to get this plugin? Go to plugin, manage and install plugin and type value T. So it will appear. Let's do it. So plugin, manage and install plugin, and write. It will connect with the internet, and then you write here value. So the value tool plugin will appear. Install this plugin. Connection issue. Let me connect with this. I'm now connected. Let me install it again. The value tool is being installed. Uh, yes, plugin installed successfully. Okay, and the plugin is appearing here. Let's see. Let me check. It says host, plugin host not found. Let me check whether it is found or not. Plugins.qgis.org not found. But if I remove this one, I think that was old message. And if I search value T, so this value tool is already installed. That was previous message which appeared. Let me check by using this tool. So if I'm able to use this tool, then I'm okay. The new tool appear in the tool panel. The new value tool panel will appear. Value tool panel. Okay. So let me check. Where is value tool panel? Yeah, here. A value tool panel has appeared. Yes, it is here. If you close the panel, you can reopen it from View Panel Value Tool. So let's close and reopen. So how we can reopen View Panel and a Value Tool? It is here. To use the plugin, just check Enable Check and be sure that SRTM 4119 layer is active, checked in the layer panel. Okay, so what is required is two checks are required, one check over here, the other check over here, in order to use this tool. Move the cursor over the map to see the pixel value. If I move the cursor, I will see the pixel value. So let's do it. So enable is already checked, and from here only SRTM is checked. Uh, yeah. And now if I move my cursor, I can see the value row and column for each pixel. You can see it over here as well. Okay. But there is more. The value tool plugin allow you to query all the active raster layer in the layer panel. It can also check other results, other layers. Set the aspect and slope layer active and hover over the map again. So we can have multiple check. Let's check the slope. Let's check the aspect. And now I'm going to hover. Now see here, you can check three values at a time: aspect, slope, and SRTM. Okay. Some value of the slope are quite interesting to observe. Like for example, 4, here the slope is 4, 3 dot dot dot. So what this dot 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 mean? I think now it is corrected. What is conclusion? You have seen how to derive all kind of analysis product from a DEM. What are those analysis product? These include hillshades, slope, and aspect calculation. You have also seen how to use Raster Calculator to further analyze and combine these results. Finally, you learned how to reclassify a layer and how to query the result. What's next? Now you have two analyses. The vector analysis, which shows you the potentially suitable plots, and raster analysis that shows you the potentially suitable terrain. How can these be combined to arrive at final result for this problem? So before that, there was a vector analysis for choosing a plot. Then we had raster analysis for choosing the plot, and in the next module we are going to combine the two results. That's the topic for the next lesson starting in the next module. So This ends the chapter 7. That's it. Thank you.